Welcome. In this video series, we're going to look at the trigonometric functions. And again, the premise of this is that we've talked about trigonometric points already. And so now we're ready to move on from there. And so as you can see, the start of the trigonometric function definition is here. There's a little bit more down below. But when we talk about trigonometric functions, we're talking about using the trigonometric points. And so you can see t is a real number, measure along the circumference. Okay, all that's just saying P of t is a trigonometric point and it has coordinates x, y. That's really what we have to take away from that. Okay, and so then with the trigonometric point, when we look at that, if we're looking at the y coordinate of the trigonometric point, that is our sine function, spelled S-I-N-E. When we write it mathematically, we typically just write it as S-I-N, all lowercase, and then parentheses t. So this is a function where we put in that arc length or that in some cases, remember the arc length is the same as reference number, sometimes not, but we're putting in that arc length along the circumference, getting out the y coordinate. Okay, cosine, so again, that's how it's spelled, abbreviated COS, and then again, insert arc length, we get out the x coordinate from that trigonometric point. And then the other main ones, so these highlighted yellow ones are the main ones that we use. The other one is tangent, abbreviated tan. And when we calculate tangent of the arc length, okay, again, a function, we get the y coordinate over the x coordinate. And since sine is y and cosine is x, we can also write this as sine t over cosine t. An important little caveat here is that when we're working with tangent, we have to have that the x coordinate is not 0. Otherwise, we're dividing by 0, bad things happen. To go along with these three main functions, we have what we think of as their reciprocal functions. So when we look at cotangent, cotangent is going to be the reciprocal, meaning interchange numerator and denominator. So cotangent is the reciprocal of tangent. So instead of tangent being y over x, or sorry, tangent is y over x, cotangent would be x over y. Secant is the reciprocal of cosine, 1 over x. Secant is 1 over x, and then cosecant, when we work with that, that's the reciprocal of sine, so 1 over y, okay? And so again, just so we can visualize this in a quick little diagram, again, if we're thinking we have the unit circle, it's a rough sketch, and we have trigonometric point. I'm going to put it in quadrant 2 just for fun, call that point P of t, and this has a x, y coordinate associated to it. Again, the arc length here along the perimeter or along the circumference of the circle would be t. And so if we're looking at, say, sine of t, what we're saying is this is going to be the y coordinate. These are just definitions, okay? Some notation pieces. Sine of t, when I write it, I'm going to write it with parentheses around t, just so we can very clearly see this is the input, this is the domain, right? And then we get out the range from it. And then a lot of the times in the textbook, you're going to see it written without parentheses. You can imagine there's parentheses there. What we have to be careful about, and this is a big mistake that many students make, is that when we see this written as sine t without parentheses, we think that there is a multiplication sign, so that there's two different things. No, sine is a function. It needs an input, and we get an output, okay? And then also, with all these definitions, we, by default, assume that t is positive, right? So it goes in a counterclockwise fashion. If t is less than 0, what happens? It goes clockwise, right? It would just go so negative t would look something like going from 1, 0 around the other way along the unit circle. Definitions still apply. Okay, so just as a quick wrap up here, an example. Okay, so we have P of t as a trigonometric point with coordinates that. We want to draw t and then determine the value of the 6 trig functions at this value of t. Okay, so again, I like getting a drawing first, so I'm just going to get a little sketch going, draw a lovely unit circle. That is not a great circle, but we're going to roll with it. And so we want to put this point on our diagram. So negative 3/5, I don't know about there, 4/5, maybe something like that. I'm going to label that negative 3/5, 4/5. Okay, so that's my trigonometric point as long as I include t. Oops, I wanted that in red. T would extend from 1, 0 along the circumference of the unit circle up until there. Okay, so that's t. All right. It says determine the value of the 6 trig functions. So we have sine and cosine, tangent and cotangent, secant and cosecant. Okay. Eventually, we'll talk about why I write them like this. As long as you provide the 6 of them, I don't care what order they're in, but I write them this way on purpose. Okay. More on that in a later video. All right. So sine, again, sine is just going to be the y coordinate from our trigonometric point. So this is y, which is in this case just 4/5. Okay, cosine is just the x coordinate, which is -3/5. Okay, tangent would be y divided by x. So this is 4/5 divided by -3/5. And if I simplify that, multiply by 5 to numerator and denominator, I'd get 4/-3, -4/3. Okay, cotangent would just be now the reciprocal x over y. Okay, or you can just say flip numerator and denominator from tangent. So instead of -4/3, -3/4. Secant would be the reciprocal of cosine. So again, interchange numerator and denominator, -5/3. And cosecant would be 1/y, or the reciprocal of sine. So 5/4. Okay, so trig functions, we define them using trigonometric points, and once we have a trigonometric point, we have just the straight definition. Sine and cosine are really essential for us to know. Sine is the y coordinate, x is the same as cosine, and then tangents y/x. Okay, the reciprocal functions are useful, but focus on sine, cosine, and tangent first.